Hey everyone, welcome to this video of the OSPF graphing series that I've been doing. In this video, we're going to go over how OSPF recurses to external destinations. Now, in the last video, we saw how OSPF recurses to a Type 3 LSA. And remember, that's an LSA coming from an inter-area route. And in that video, we saw that OSPF doesn't really care what happens outside of the network. It uses SPF to, find the shortest path to the ABR, and then the ABR takes care of, the shortest path to the destination. So in this video, we're going to introduce Type 4 and Type 5 LSAs to see how OSPF recurses to an external route. So again, just like last video, I'm not going to go through LSA by LSA to do the whole map by hand. Instead, I'm already showing you what the topology looks like so that I could quickly go over what routes we're injecting into the OSPF process, and then we'll go over how OSPF recurses to them. So in this look here, we're going to be focusing on R4's perspective of the graph. And the reason is because I have two areas. So I'll just draw this here. This is going to be area 1. Area 1. Everything else is going to be in area 0. We're going to be injecting routes in two different places. R1, we're going to have an OE2 route, and it's going to be the loopback of R1. And then R6 is also going to have an OE2 route, which is going to be the loopback of R6. This way we could take a look at how OSPF views an external route from within the area and then an external route from outside the area. So first things first is we're going to go on R4 and let's take a look at the database. All right, so what I'm going to do actually is I'm going to get rid of this now that you've all seen the topology. I'm going to go ahead and remove that from the screen and we'll start doing our drawings. So let's make this full screen. All right, now here's the full OSPF database on R4. You can see here that we actually have two Type 5 LSAs, which are the AS external link states. And we have the loopback of 1 and the loopback of 6. And then we have a summary ASB link state, and we only have one for R1. So already we can see the difference between an inter-area ASBR and an intra-area ASBR. Another spot we could take a look at that is, again, with the show IP OSPF, border router. Can't spell. Helps if you can spell. Border routers command. So here we can see we have 3 different border routers actually, and this makes sense because, let me get rid of that little mark there. We have router 6, which is an ASBR. It's external. It's doing redistribution. So it's putting external routes into the OSPF process. Then we have router 2, which is an ABR. And then router 1, which is an ASBR, but it's not in our area. All right. So now that we kind of have a better look of, better understanding of the topology, let's go ahead and see how R4 recurses to the external route of 6's loopback. So again, we could see that, let's just do show IP OSPF database, and I'll begin at Type 5. So we're going to want to do recursion to 6.6.6.6. So we'll show IP OSPF database for external. And actually, to get that down even further, let me sorry, external, and we'll do all sixes. Okay. So we can see here that we have an external. Here's the link state ID. And we can see the advertising router here is sixes. The forwarding address is 0. When the forwarding address is all zeros, it just means that the forwarding address is the advertising router. So in our case, OSPF knows to recurse to this destination, it needs to take a look at this router LSA. So let's go ahead and take a look. Show IP OSPF database, and we'll do router. Okay. So we're on R4, and I guess I should start doing some drawing so we can draw this out. So the first thing we'll do is we know we have this external route. We'll say it's an E2. We know it's an external route. And the ASBR is 6. And we knew that from the Type 5 LSA. The other thing we could see too is that the metric is 20. So I'll go ahead and put that there. Our metric is 20. Okay. Now we take a look at the advertising routers Type 1 LSA, and we can see a few things about it. One is we have a point-to-point link to R4, which happens to be the router that we are on. So let's say R4. And the metric is 1. Metric is 1. It's a stub network. We could see the addresses. Router 6 also has a point-to-point to R5, but that's really all we need in this situation. So to kind of quickly recap, we had a Type 5 LSA, which recursed to the Type 1 LSA, and that is how we know our path to get to that destination. The other thing we know is that the metric theoretically should be 21, because 20 plus 1. So let's go ahead into the routing table and take a look at what we have. All right. We could see the known OSPF metric of 20. That's interesting. Type external 2, but the forward metric is 1. And we could see we're learning it from router 6. All right, so what does this mean? Well, the metric clearly wasn't 21. The metric was actually 20. Why did that happen? Well, it has to do with this. With an OE2 route, the metric that gets installed into the routing table is the metric that was injected into the process during redistribution. It doesn't add the metric from 6 to 1 in there. That's why the metric is 20. So it doesn't really matter where we go in the network. Let's say we could take a look back at our topology. Let's take another hop up to R2, which we know is going to be further away. So let's go to R2 and show IP route. We could see here again that the route metric is 20. But in this case, the forward metric is 2. Our metric is still 20, but the forward metric is 2. So what I just wanted to point out here is that even though all the routers in the network are going to have a metric of 20 because it's a Type 2 external, doesn't mean that so let's take R4 to R2 here. It doesn't mean that the metrics to get to the ASBR don't matter. It does actually matter. So if we had another link that, let's say we went down here and it was 1, and then 1, and then 1, and then 1, we would be learning the route from two different places, and they would both be coming in. So this route would come in here with a metric of 20, and this route over here would come in with a metric of 20. But that doesn't mean that OSPF would do equal cost ECMP, equal cost multipathing, load balancing, even though the metrics are the same. And that's because of the forward metric. So the forward metric for this route down here would be 1, 2, 3, 4. And the forward metric up here, the forward metric is 2. So OSPF is still going to prefer this route, because basically what we're doing is we're going to solve shortest path to the ASBR. And in this case, our shortest path has a metric of 2. So again, just because you see 20 in the routing table doesn't tell the whole story. You still have to look at the forward metric to see which path your traffic is going to take. So if we go back to R4, and let's get rid of some of this stuff. All right. Okay. So now we can see how the recursion works. We're doing the recursion for the external route from a 5 to 1. Now this is great on an intra-area ASBR. Now let's take a look at an inter-area ASBR, and specifically we have show IP OSPF database, and let's just do it include 1.1. Well, that's actually a poor example. Let's do show IP OSPF database, begin, let's begin external. Okay, so now we have the type 5 LSA for 1. So show IP OSPF database. Sorry, it's an external, and it's 1.1.1.1. All right, so now this is going to be a little bit different, because we have our link state ID of 1.1.1.1, the advertising router is 1, and the forward address is 0. So remember what that meant. That meant that if the forward address is 0, we go to whatever the advertising router, that becomes the forwarding address. Okay, so we know our forwarding address needs to be 1.1.1.1. But if we look in show IP OSPF database, I currently still haven't. Hold on one second. This is going to age out. I think this is a remnant from an older lab. So let me just pause the video and let this age out. Okay, sorry about that. Should have cleared my OSPF processes in between doing videos, so that my link state database was up to date. So let's do a show IP OSPF database again. And now we can see that our router link states, we don't have a link ID for 1.1.1.1. So even though the forwarding address was to that router, we need to learn how to get there. And that is the point of the summary ASB link state, or the type 4 LSA. So in order to take a look how this works, we're going to go ahead and draw it out again. So we'll go over here and we'll say we have this route again to the destination. It's an E2 external. The forwarding address is R1. It had a metric of 20. It's an OE2 route. I didn't make any changes. But now we need to learn how to get to R1. So let's go ahead into this type 4 LSA and take a look at what that says. So it's going to be show IP OSPF database, and this time it's going to be the ASBR summary. And the specific summary is 1.1.1.1. So it's a pretty short LSA. It doesn't have a ton of information, but it has plenty of vital information. So we can see the AS boundary router address is all ones. And we can see the advertising router is twos, and the metric is 1. So this means that between R1 and R2, there's a metric of 1. Now, this metric just happens to be 1 in our case because these two routers are directly connected. But this metric would be the actual OSPF metric from R2 to get to the wherever the ASBR is. So, okay, now in this case, we know that the metric is 1. And we know now that the advertising router is all 2s. And now OSPF can do some recursion. And we'll do show IP OSPF router. Database router type 1 LSA for 2.2.2.2, which we have because it's in our area. And now we could take a look at the type 1 LSA, which we have. We're connected to a stub network to 2s, which is our loopback. We're connected to a transit network, and then we're connected to a point-to-point to R5, with a neighboring ID of 5s. So if we draw out 2, we could say 2 is connected to 5. Then 2 is connected to this DR. So we'll go down here. We have a designated router. And the TOS metrics there is 1. Okay. So now we could take a look at the show IP OSPF database for the network of 10.0.234.4, which again, that comes from the type 2 LSA, which was right here. And now we can see we're connected to 3 routers. We're connected to R4, R2, and R3. So we're already connected to 2, connected to 3, and we're connected to 4, which is us. And that's an awful circle. Let me let me get a little bit better. Still not a perfect circle, but at least it's connected. So, what does this mean now? Well, we could take a look at our own type 1 LSA if we really wanted. Show IP OSPF database router 4.4.4.4, and we could see that connected to that transit network, we also have a metric of 1, and we know from previous videos that with the DR, it's a pseudo node, so the total cost of this link is 1. So let's take a look at what we know, and let's see if we can figure out what the router metrics, or the metric in the routing table should be. I'm going to erase these that don't matter. I'll erase this too, just so we can have a clearer picture. So what we should see is we know it's an OE2 route, so the metric should still equal 20. Then we have from 4 to 2 is 1, so the cost to the ABR equals 1, but then the cost to the ASBR equals 2. All right, So let's take a look at R4's routing table. Show IP route. Up 6. And what we can see is the type is external 2, the metric is 20, and the forward metric is 1. It's not 2. And that's because of the way we're doing our recursion. So we have here are the LSAs. We have 5, which recurse to 4, which recursed to 1. At the end of the day with OSPF, to get to the type 5 LSA, we're eventually recursing to the type 1 LSA. And in this case, from 4 to get to 2, the forward metric is going to just be 1. And this is how OSPF, again, makes its decisions. So let's say we had a second AS or ABR in our area. Let's say we had 4 to here, to here, to here, which is connected to 1. And here's the area boundary, right? 1, 1, 1. OSPF really, because it doesn't know what the link state database looks like outside of the area. It can only know what's in its own area. So here the forward metric would be 3, and it would choose this path from 4 to 2 to go out the network. There are a lot of reasons why that might be different, or there are a lot of cases that we can look at to see how OSPF does some more complex routing. And actually this one here with 2 different ABRs connected there could get a little bit complicated. It could also get complicated doing multiple ASBRs to the same destination. But at the end of the day, what you really need to just remember is we have the type 5 LSA that we're learning from R1. We have the type 4 LSA, which tells us how to get to R1, specifically which ABR to use to get to R1. And then we recurse to the type 1 LSA that tells us how to get to that ABR. So I hope this was clear. If you have any questions or comments, please leave them below, just in case I was a little unclear. The video went on a little bit longer than I expected it to, but that's all right. And we'll see you on the next one.